Thank you, everybody, for joining us after lunch. We have Nick Nee, a Senior Director, AI Group at AMD, leading AI developer relations and driving initiatives spanning developer conferences, hackathons, developer programs, and open source contributions. With 20 plus years across AMD, Xilinx, Altera, Qualcomm, he specializes in AI infrastructure, product strategy, and scaling emerging technologies into impactful business growth while bridging cutting-edge AI innovation with real-world adoption. Give it up for Nick.
All right, thank you. All right, good afternoon, everybody. Thank you so much for attending. My name is Nick Nee, and I run the AI DevRel team at the AMD. And in fact, this whole developer track happened to be run by our team. So thank you so much for attending, and I hope you're enjoying this show. By the way, we have a very exciting fireside chat coming up at 4:30 by Lisa Su and Clem, so definitely stick around for that as well. So I have a huge honor to kind of introduce or double-click into the ROCm AI that was just announced. Hopefully, everybody were at the keynote. Yeah, awesome. So yeah, Vamsi Bopana, our Senior Vice President, has announced the ROCm AI, and I'd like to take this opportunity to slightly double-click. Actually, after this session, there's a triple click on the Hyperloom, so definitely welcome you to stay and then understand more about that as well. Okay, just again, quick recap on a few things I was discussing in the keynote, right? So I think at this point, the world is pretty convinced that AMD has a very strong hardware from data center to the client to the server. But really, it's the software and the ecosystem that makes or breaks developers like yourself. So, I mean, we've known this, and we've formed the AI group. We've been investing very heavily for the last few years. And hopefully, you are seeing the improvements in the ROCm and a lot of the ecosystem. So, you know, some of the things we've really invested early is the Hugging Face, right? All the models that come out of every day, first thing, it gets hosted on the Hugging Face, supports on the Transformer library. 3 years ago, we've announced a partnership with them, so they're testing this daily. So everything comes out on the day zero is supported on the Transformer library. That made a huge difference. The top open source community projects are super important, right? Chances are you're probably using some of the top frameworks to do your training, to your RL, to your inference. So it's super important for us to support all the features that comes out on the day zero. And then we've been working, relentlessly with the community to increase the contribution. So starting from our own, stepping up our own contributions to the community, but also the community itself is really driving almost 10x increase in the contribution in the last 12 months. So it's very good to see, and thank you so much for that. So our strategy has been, again, very consistent, right? Open source is how we really, enable the innovations, and I think you probably heard from Anthropic today too, that open source really helped us also train the AI agents much more effectively. Because we've run so many open source libraries and contests, there are, in fact, way more HIP code and the AMD GPU code out there than CUDA in open source. And as a result, AI agents are learning these, and we're seeing OpenAI within Anthropic really improving their models on the AMD GPUs. That's a huge win. The abstraction is very important too. Let's face it, the GPU program is very niche. Like, you have to know GPUs, you have to know many cores. How do you do a synchronization? It's a pretty difficult skills for a lot of people. So raising the abstraction to something like a Pythonic level will really widen, right, the number of people who can develop GPUs. But even for those of you who develop GPUs already, we give you the time to performance improvements by going higher abstraction layer. And I'll talk more about that during the talk as well. So the open source, again, these are some of the most important frameworks. We have daily CIs. We support them when the new feature come out. So chances are you're probably developing your projects using one of those frameworks, and it's supported seamlessly. The models are super important. So not only we support day zero, we actually work with most of these frontier model companies even before they release it. So we make sure everything is working on the day zero. On the abstraction, I want to maybe zoom into one example that we launched. So, Phil Tillett from OpenAI was on the keynote, and he talked about the Triton and the Gluon. That's a great example. We've also, from AMD, launched something called Fly DSL. And this is basically Pythonic DSL language, right? So this is a kind of simple example on the left side. We're using CUDA HIP-like programming. Again, it's very writable, but you do have to understand all the many cores, how the memories are being shared. You have to write basically code for each of the engines, and then you have to think about the corner cases and how do you synchronize them, all that. It does take a lot of those thinking there. On the other hand, if you write this in the Pythonic DSLs, it looks much more like algorithm. Like you're writing a sequential algorithm, and the compiler in many cases will take care of these synchronization and the mapping to the many cores. So it's definitely much more algorithm focused, and it's easier to write. But also debugging and profiling is easier, right? So because you're not trying to debug the synchronizations and corner cases as much as the traditional use case, it actually gives you a faster time to performance, time to product as well. Okay, but here, we're really here to talk about AI Assist, right? This is a really exciting feature, which really enable us to create something called ROCm AI. It's how do we use, and our philosophy was very simple. How do we allow developers to use natural language, like English or any other languages, to basically program GPUs? Basically, that's our simple goal, right? So whether you're trying to do some inference using VLM with some model that came up on the Hugging Face 2 days ago, or I'm trying to do some reinforcement learning, or maybe I'm just trying to profile my GPU code, I don't want you to learn like 5 different things or go through 10 different user guides. Basically, I want you to just type what you want to do, and hopefully now the Claude Code or Codex or whatever your favorite agents, right, now understand how to deal with ROCm. And that's basically the simple concept behind ROCm AI. So if you zoom into what's in the box, right? So on the bottom, the foundation is basically our ROCm core. We continue to improve. We'll add more optimized kernel libraries and et cetera. But we're adding an AI-assisted optimization layer. So this is a very complex, sophisticated agents suite that can do a typical optimization cycle, from profiling, fighting the bottlenecks, trying to figure out, do I do something on the serving framework? Do I have to fill some kernels? Do I have to write some kernels? Do I have to do some validations, make sure I didn't break any accuracy? All of that kind of cycle that typical people will go through, now we're making agents help you go through even faster. So that's what the Hyperloom is, and I believe we have the Hyperloom conversation right after this. And then the AI skills. So we're trying to meet where you are, right? I believe most of you are probably using one of those agents. Actually, can I just see your hands? I mean, how many of you are using Claude Code mostly? Codex? Cursor? Gemini? Copilot? Your own special framework? Awesome. Well, so that's where we want to meet you, right? So we already have many of those ROCm skills that's natively integrated into Claude, into Codex, into Cursor, and more so now in the Gemini, in even the Copilot right now. So this is something we're going to continue to increase the amount of recipes and the skills that you can use directly. So here's an example of OpenAI Codex, right? So you can basically, in your Codex environments, you can look for the plugins, and we already have the AMD skills that's already enabled. So you can just, as simple as import that as a plugin. Right now, I think we have like 5 or 6 different skills already usable, and we'll continue to increase and have more sophisticated skills as we go. Same thing for the Claude. Again, you can use the plugin. You should be able to type in AMD skills and discover it, and again, enable just within your Claude code. Again, same thing for the Cursor. Okay, so let me just kind of double click on the demo that was shown in the keynote. So this was shown as a running DeepSeek version 4 Pro on the Helios. So as you can see, the prompt was as simple as run DeepSeek v4 on Helios. So that's as simple as we want this input to be, right? Now under the hood, it's doing all the things that typically you have to do manually, which probably you pull the model from Hugging Face, you have all the tokens, you have to set up, maybe set up the Docker for the VLM, you should know what's the right configurations of the serving, et cetera, pull in the right kind of defaults. Of course, I haven't even talked about the health check of the GPUs, make sure the model fits, right? You may have to pick the right kind of quantizations if somehow the memory doesn't fit, etc. So typically you go through all that steps. Basically with the one single prompt, we're able to just launch the VLM, launch the APIs, and you are able to connect as a client and here doing a simple point. But of course it could be anything else. So that just significantly simplified how to get some model serving on the MI355 quite significantly by having the right kind of recipes, right skills in the claw code in this case. So from claw code, you could just use a prompt and trigger a whole bunch of ROCm knowledge. Okay, so now I want to just quickly touch Hyperloom. I'm sure the next section is going to go into a lot more details. So this is, like I mentioned, the typical kind of 5 steps, right, that people go through. So first, okay, let's just say we started from that, the model DeepSeek, right? Let's say the performance was pretty decent, but you feel like you can do better than that, right? So the first thing is you want to establish a performance baseline. You know what's the performance, what's the interactivity, what's the number of concurrency you can run, and based on that, do a profiling, trace it, and then you can probably see some hotspots. Maybe there's some inefficiency in the communications. Maybe there's some kernels that are taking a long time. Maybe there's something else that's funky, right? So you run these traces, and based on that, probably the first thing is like, hey, is it at the framework level, right? Can we tune something? It could be as simple as some parameter changes or just pulling some different libraries. And in fact, right now, AMD is publishing a lot of optimized libraries every day, but community, right, is also contributing a lot of good libraries. So, there's a little bit of search space you have to do also to find what's the right kind of library for the particular kernel, for the particular shape, etc. And then finally, maybe there's something missing, right? Maybe there is an opportunity to write a new GPU kernels or maybe even fuse some kernels. And that's something, Hyperloom can do as well. So again, double clicking into the demo that was shown on the keynote, right? So in this case, we were talking about maybe optimizing Minimax M3, which is a pretty recent model, right? So Hyperloom basically spawns multiple agents and then just goes through this. Of course, this is a sped up video. It does take a little longer than this, but it goes through all the performance traces and finding the bottlenecks. And then in this case, it actually finds 3 different opportunities to improve. So let's wait till the end. So in this case, I think the Hyperloom actually found a shared expert fusion. So in the Minimax, there's a shared experts followed by a bunch of routed experts, right? So it found the opportunity to fuse them so that you actually have less kernel launch overheads and then less memory back and forth. So basically, Hyperloom did the fusion for you. You also found the opportunity to pick a different library for attention. So I think the VLM default library in this case wasn't the most optimal, right? And the Aider, which is one of the open source projects from AMD, had a better attention for this case. So he actually picked it, and it increased by another 6.5%. And then finally, there's a tool called Geek within the Hyperloom that can actually generate GPU code. And he actually decided to optimize for the L2 cache. So in the MOE group jam, I think he saw opportunity to have a better cache hit rate by having an L2 sizzle pattern. So he actually regenerated the kernel with that pattern inserted into the MOE group gem. And that was another huge boost. So you can see like all these things, right? Hyperloom were trying one by one, and at the end, they combined them all into a whole model serving, upgraded Docker, and then at the end, it was able to get 38.3% improvement at the end-to-end model execution level. Again, if you just go back, what was the input? Basically, optimize Minimax M3 on the Hyperloom, and it was that simple, right? So this is like a really great example where, this kind of AI agent assistance will really help in iterating the performance. Okay, so I think short and sweet. I just want to wrap it up, and then there'll be a lot of interesting talks after this. So, I just want to really wrap it up. So, again, open, right? Open source has been very, very important to AMD's strategy. And as you saw, day 0 support of models and framework is what we're really striving for. And then the higher level abstraction, right, really widens the number of developers who can reprogram GPUs and bring in the higher productivity to those of you who already know how to program. And then today we focus on the AI assist features, right? We talk about the skills, which really allow you to use plain English or plain, or what language of your choice to use ROCm, as well as have sophisticated agents help you optimize trace, profile, all these end-to-end model performance. And then we're really making ROCm everywhere available. So not just Instinct GPUs, but on the Radeon GPUs. And now we're talking a lot about the Strix, and we just launched the new Strix Halo box, right? All of that is working as a unified ROCm software. So you can go from cloud to the client. It's a quite exciting time. So ROCm AI, we're planning to release publicly in August. So definitely stay tuned and love your feedback when it comes out. Thank you so much.